cord feeding the portable heater can indeed be sized for a maximum draw of 30 amps. The 50 amp breaker serves specifically to protect the welding receptacle and the number 80HHN wire from overload conditions. It does not govern the sizing of the cord that is plugged into the receptacle. Article 240.5b of the National Electrical Code clarifies that the ampacity of a cord must not be less than the ampacity of the branch circuit it serves. In this scenario, the branch circuit is the welding receptacle, which has a rating of 60 amps. However, because the heater itself is only rated for 18 amps, the cord is not obligated to be rated for the full 60 amps of the receptacle. Table 400.50 within the National Electrical Code provides detailed information on the ampacity of cords for various wire sizes. For instance, a number 10 THHN wire has an ampacity of 30 amps. This ampacity is sufficient for the heater, which draws a maximum of 18 amps. Article 210 of the National Electrical Code, while not directly addressing the ampacity of cords, emphasizes that cords should be used in accordance with their ampacity ratings. This means that the cord in this setup should be rated for at least 30 amps, which corresponds to the heater's maximum current draw. Therefore, the cord that connects to the disconnect and plugs into the 60 amp welding outlet can be appropriately sized for a maximum draw of 30 amps, aligning with the heater's requirements and adhering to the relevant electrical codes and standards. To elaborate further on the selection of the appropriate cord for this application, firstly, it's crucial to understand the purpose of each component within the electrical circuit. The 50 amp breaker is in place to protect the number 8 THHN wire that feeds the 60 amp welding receptacle. This means the breaker will trip if the current flowing through the number 8 THHN wire exceeds 50 amps, preventing overheating and potential fire hazards. Secondly, the 60 amp welding receptacle provides a convenient and readily available power source. However, it is essential to recognize that the receptacle's ampacity rating indicates the maximum current it can safely handle, not necessarily the current that all connected devices must draw. Thirdly, the portable heater is the load in this circuit, and its current draw determines the appropriate cord size. The manufacturer specifies that the heater draws a maximum of 18 amps and requires 20 amps low-blow fuses for protection. The 30 amp fuse disconnect mounted on the heater provides local overcurrent protection, ensuring that the heater and its internal components are protected from excessive current draw. Regarding cord selection, Table 400.5 is a key resource. This table outlines the allowable ampacities for various types and sizes of flexible cords. When choosing a cord, it is vital to consider not only the ampacity but also the cord's suitability for the environment in which it will be used. For example, if the heater is used in a damp or wet location, a cord rated for wet location should be selected. Similarly, if the cord will be exposed to oil, grease, or chemicals, a cord with a chemical-resistant jacket should be chosen. In this specific scenario, a number 10 THHN cord with an ampacity of 30 amps would be a suitable choice, as it exceeds the heater's maximum current draw of 18 amps and aligns with the 30 amp fuse disconnect. It is important to note that the National Electrical Code provides minimum requirements for electrical safety. While a number 10 THHN cord is sufficient in this case, a larger cord could also be used if desired. However, using a larger cord would not provide any additional protection and would simply increase the cost and weight of the cord. Furthermore, Article 210 provides general requirements for branch circuits, including the proper use of cords and cables. This article emphasizes the importance of using cords in accordance with their ampacity ratings and ensuring that cords are not subjected to excessive strain or abuse. In summary, selecting the appropriate cord for a portable heater connected to a 60 amp welding receptacle requires careful consideration of the heater's current draw, the ampacity of the receptacle, and the relevant National Electrical Code articles and tables. By following these guidelines, it is possible to ensure a safe and compliant electrical installation. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring or safety. Additionally, it is important to understand the role of overcurrent protection in electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical wiring and equipment from damage caused by excessive current flow. When selecting an overcurrent protection device, it is crucial to choose a device with an appropriate ampacity rating for the circuit it is protecting. In this case, the 50-amp breaker protects the number 8 THHN wire feeding a 60-amp welding receptacle. If the current flowing through the number 8 THHN wire exceeds 50 amps, the breaker will trip, interrupting the flow of electricity and preventing overheating. The 20-amp slow-blow fuses in the heater's fuse disconnect provide overcurrent protection for the heater's internal component. Slow-blow fuses are designed to withstand temporary overloads, such as those that may occur when the heater is first turned on, without tripping. However, if the current exceeds 20 amps for an extended period, the fuses will blow, protecting the heater from damage. Regarding the use of extension cords with portable heaters, it is generally recommended to avoid using extension cords whenever possible. Extension cords can introduce additional resistance into the circuit, which can cause the cord to overheat and potentially create a fire hazard. If an extension cord must be used, it should be sized appropriately for the heater's current draw and should be as short as possible. It is also important to ensure that the extension cord is in good condition and is not damaged or frayed. When working with electrical equipment, it is essential to follow all safety precautions and to use appropriate personal protective equipment, such as safety glasses and gloves. Always disconnect the power supply before working on any electrical equipment and verify that the circuit is de-energized using a voltage tester. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to perform the work. Ignoring electrical safety precautions can lead to serious injury or even death. In addition to the National Electrical Code, local electrical codes and regulations may also apply. It is important to check with your local building department or electrical inspector to ensure that your electrical installation complies with all applicable codes and regulations. Electrical codes are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest code requirements to ensure that your electrical installations are safe and compliant. Continuing education courses and industry publications can help you stay informed about changes to the electrical code. Finally, remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not a qualified electrician, it is best to leave electrical work to the professionals. Hiring a qualified electrician can help ensure that your electrical installations are safe, compliant, and reliable. Furthermore, the type of portable heater being used can influence the best practices for cord sizing and overcurrent protection. For example, if the heater utilizes resistive heating elements, the current draw will be relatively constant. However, if the heater incorporates a motor, such as a fan, the inrush current during startup may be significantly higher than the normal operating current. Inrush current can cause nuisance tripping of circuit breakers or fuses, so it is important to select overcurrent protection devices that are appropriately sized to handle the inrush current. Similarly, the cord should be sized to accommodate the inrush current to prevent overheating. Some portable heaters may also incorporate electronic controls, such as thermostats or timers. These electronic controls can be sensitive to voltage fluctuations or electrical noise. It is important to ensure that the heater is connected to a clean and stable power source to prevent damage to the electronic controls. Additionally, surge protection may be necessary to protect the electronic controls from damage caused by voltage surges. The environment in which the portable heater is used can also affect the cord selection and safety precautions. For example, if the heater is used in a dusty or dirty environment, it is important to clean the heater regularly to prevent the accumulation of dust and debris, which can reduce airflow and cause the heater to overheat. If the heater is used in a hazardous location, such as an area where flammable materials are present, special precautions must be taken to prevent ignition. Explosion-proof heaters and cords are available for use in hazardous locations. These heaters and cords are designed to contain any sparks or explosions that may occur within the device, preventing them from igniting the surrounding atmosphere. Regular inspection and maintenance of portable heaters are essential for ensuring safe and reliable operation. Check the cord for damage or wear, and replace it if necessary. Clean the heater regularly to remove dust and debris. Inspect the heating elements and other components for signs of damage, and repair or replace them as needed. By following these maintenance practices, you can help extend the life of your portable heater and prevent potential hazards. Consider the specific application and potential hazards associated with the environment when choosing a portable heater and accessories. By carefully selecting the right equipment and following all safety precautions, you can ensure a safe and comfortable heating experience. Also, consider the length of the cord needed. While keeping it as short as possible is ideal, sometimes a longer cord is necessary to reach the power source. In such cases, ensure the cord is adequately sized for the length to prevent voltage drop, which could affect the heater's performance and potentially damage it. Voltage drop occurs when the voltage at the heater is lower than the voltage at the power source due to the resistance of the cord. The longer the cord and the smaller the wire gauge, the greater the voltage drop. To minimize voltage drop, use a larger gauge cord for longer runs. There are voltage drop calculators available online that can help you determine the appropriate core size for a given length and current draw. Furthermore, be mindful of how the cord is routed and protected. Avoid running the cord through doorways or under carpets, where it can be damaged or create a tripping hazard. Use cord protectors to shield the cord from damage in high traffic areas. Keep the cord away from heat sources and sharp objects. When not in use, store the cord properly to prevent damage and tangling. Coil the cord loosely and secure it with a hook and loop fastener or cord reel. Avoid tightly wrapping the cord, as this can damage the wires inside. Store the cord in a cool, dry place away from direct sunlight. Educate users about the safe operation of portable heaters and the importance of proper cord management. Provide clear instructions on how to plug in and unplug the heater, how to adjust the settings, and how to maintain the heater and cord. Emphasize the importance of not overloading the circuit and of not using damaged or frayed cords. By promoting safe operating practices, you can help prevent accidents and ensure the longevity of the heater and cord. Periodically review the electrical codes and safety standards related to portable heaters and cords to stay informed of any changes or updates. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. By staying up to date on the latest requirements, you can ensure that your electrical installations are safe and compliant. Consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical safety. They can provide expert guidance and help you ensure that your electrical installations meet all applicable codes and standards. Also, document all electrical work performed, including cord size and calculations, overcurrent protection device selections, and safety inspections. Maintaining accurate records can help you track the performance of your electrical systems and identify potential problems before they become serious. Documentation can also be helpful in the event of an insurance claim or a safety investigation. And remember to prioritize safety above all else. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always disconnect the power supply before working on any electrical equipment, and verify that the circuit is de-energized using a voltage tester. Wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to perform the work.